This is the third page for the Chapter 6 test review. This is where we're going to deal with interest and, compound interest. None of the problems in the review deal with exponential growth or decay, but if you have a problem that does not use the word compounded, if it's growing, you use the growth. If it's decay, you use the decay. On the test, I gave you the equation for each problem that you will use. So on number 16, it says we have 5,000 is deposited in an account that pays 1.25% compounded quarterly. How much will the account will be in the account after 20 years? Okay, so compounded tells us we're using one of the first two equations, and quarterly means we're going to use the compound interest. It would use the word continuously if I use the other equation. But like I said, on the test, I give you the equation, and this one, I would have given you this equation. That is the one we're going to use. Okay, so I have variables A, P, R, N, and T. Those are the variables inside this equation. A is the amount that I have after however many years, which is what I'm trying to find in this problem. So that's my question mark. I don't know what that is. P is the principal amount or your initial amount, which this problem told us was $5,000. The R is the rate, which is 1.25%, but we have to write it as a decimal. So you move the decimal to the left two places, so it's 0.0125. N is the number of times it is compounded within a year, and quarterly means 4 times a year. And then T is how long is our time frame here, and our time frame is 20 years. So I plug in what I know. I do not know A. I know P was 5,000. Then I have 1 plus 0.0125 over 4, and I have 4 times 20 as my power. And you can type all of this in your calculator. If you leave 4 times 20, make sure you put parentheses, or you could have put to the power of 80, because 4 times 20 is 80. And just type that all in where parentheses need to go and everything, and you should get the answer of $6,417.62. It is money, so you need to round to the 100th place, 2 decimal places. All right. Now, number 17 tells us specifically compounded continuously. So how much money was deposited in an account 5 years ago that pays 5% compounded continuously? The account currently has 5,000 in it. So compounded continuously is this formula. I have the variables A, P, R, and T. A is the amount in it after however many years. Well, it tells us currently, which is now, after so many years, it has 5,000. P is the initial amount, and this says, well, how much was deposited? Well, we don't know that, so that's what we're finding. The rate is 5%. We need to move the decimal 2 places to the left to get it as a decimal. And our time is 5 years. So I plug in what I know. I have 5,000 equals P. Don't know what that is yet. E is just a number. It is not a variable. And then my power is 0.05 times 5. Which, again, if you want to just go ahead and multiply that out so it's easier to plug in your calculator, that is 0.25. All right, I need to solve for the variable P. Well, it's P times e to the 0.25 power. So if I divide both sides by e to the 0.25, these ones cancel out, and I get that the initial amount, the principal that started with, is 5,000 divided by e to the 0.25 power. You have a button E in your calculator. Type all that in, and you get $3,894. And it does keep going, but it rounds to being zero change. All right, number 18. Your parents started a college fund 15 years ago with $5,000. Today there is $12,000. If the account is compounded quarterly, what is the rate the account is growing at. Okay, so it's compounded quarterly. That gives us a key of which formula we're using. That uses the one that has the N, because that's what the quarterly is going to be put in. The variables we're going to need are A, P, R, N, and T. A is the amount after the amount, or the amount of money after a certain amount of time, which we have listed as $12,000. P is the initial amount, so it started with $5,000. R is the rate, which is what we are trying to find, so that's what I don't know. N is how many times it compounds in a year, and it's quarterly, so that's 4. If it was monthly, it'd be 12. If it was daily, it'd be 365. Okay, that's how many of those things there is in a year. And this is growing for 15 years. Okay, so in the equation, plug in what we know. Well, A was 12,000. P is 5,000. Then we have 1 plus the R, we don't know, over 4. And it's 4 times 15 is the power. Okay, so 4 times 15 is 60. So let's just go ahead and do that. And then I need to solve for R. So I need to solve what's inside that parentheses. So I need to work my way inside the parentheses. I need to get rid of the 5,000 first. So I'm going to divide both sides by 5,000, and I get 2.4 equals 1 plus R over 4 to the 60th power. Now, to get rid of a power, we're going to take the root. So I take a 60th root of both sides. And now I don't have the parentheses anymore. And I'm leaving it written like that for now because if at this point you plug that in your calculator and round, your answer could look very different depending on how you round. So if you go ahead and plug in the 60th root of 2.4 in your calculator, you need to round to like 4 or 5 decimal places. The more decimal places you go, the more accurate your answer will be. Otherwise, just leave it and finish solving for R and plug in everything at once. So the next thing would be subtracting 1. So I would have 60th root of 2.4 minus 1 equals R over 4. And then you multiply all of that by 4. So R will equal 4 times the 60th root of 2.4 minus 1. And that is what you can plug in your calculator. I know it's messy, but what you can do is at this step right here, plug in 60th root, which is you push the 60 button. Then if you have a Texas Instrument, you go to Math, and it's number 5 will give you that root of any value. And since you put in the number 60, that's what it pops up to the root. And then of 2.4, and then push Enter, and you get an answer. Now, take that answer, leave it in your calculator, and subtract 1 from it. Push Enter, get an answer. And then multiply that answer by 4. Then you had to do no rounding. And at this point, you have a big decimal, and it's like 0.059. I mean, I'm rounding there. I'm just stopping at 3 decimal places. And written as a percentage, this is 5.9%. So either one of these answers is R is fine, but we are usually given the rate as a percent. If you would have rounded less than that, you would have gotten 6% or higher, a little bit higher. So that's why the way you enter it in your calculator does matter, or the way you round does matter as you go. But we're able to look at those problems when you do them on the test and see how close you actually were. So don't worry too much, but try to be as accurate as possible. All right, 19 says you made $3,000 working as a lifeguard at the Seco Pool last summer. If you invest that money in an account that pays 3% compounded continuously, how long will it take for your money to triple? So this is continuously, so that is this formula. So I have variables A, P, R, and T. So I want the final amount to be my initial amount tripled. So 3,000 tripled would be 9,000. My initial amount was 3,000. My interest is 3%, which is 0.03, and I want to know how long this is going to take. So I plug in what I know, A is 9,000, P is 3,000, E is not a variable, it is a number, but I have my rate as 0.03 and I don't know the time, so I leave T alone. So we need to get that variable out of the power, but first I have to get the E to that power by itself. So I'm going to divide both sides by 3,000, so I get 3 equals E to the 0.03T. And to get a variable out of a power, we have to log both sides. And if I log this side, it is log base E of 3 equals 0.03T. Log base E is the same thing as saying natural log of 3. Okay, that is a button in your calculator. To get T by itself, we're going to divide natural log of 3 by 0.03. We've divided both sides by 0.03. If you plug that in your calculator, you get about 36.6 years. And that concludes the Chapter 6 test review.